video, we're going to talk about how we can use the trig functions of two separate angles to find a trig function of a sum or a difference of those same angles. So we're going to start with this example. Let's read it through and kind of wrap our head around what's going on. Consider angle alpha with terminal side in quadrant 1, so like that, and the sine of alpha is 3/5. Also, angle beta has terminal side in quadrant 2, and sine of beta is equal to 3/5. We're going to use our sum and difference formulas to find the exact values of the following sums or differences. So we're going to go with this information and find the sine of alpha plus beta, the cosine of alpha plus beta, and the tangent of alpha plus beta. So let's focus on angle alpha. Let's go ahead and look at a reference right triangle and label it appropriately, right? If we know that the sine of alpha is 3/5, we can say that the opposite side is 3, the hypotenuse is 5. We can use that information with the Pythagorean theorem to solve for our missing side length. 3 squared plus x squared will equal 5 squared, which means x squared is equal to 16, and x will equal plus or minus 4. Now, knowing that angle alpha is in quadrant 1 tells us that x will be positive. Right now, we're going to do the same thing with angle beta. 3 squared plus x squared is equal to 5 squared, and x squared is equal to 16 again, and x is equal to plus or minus 4. Oops, there's our reference right triangle. Now this time, since we know that beta is in quadrant 2, we know that x will have to be -4. All right, so now let's focus our attention over here to our first trig function of a sum. Right, so we have sine of alpha plus beta here. Well, we're going to go back up and reference our expansion. So we're going to use that. We're going to say we're going to focus on the right side of the equation now, and we know that we want the sine of A times the cosine of B plus the cosine of A times the sine of B. So we're going to focus, notice I've color-coded this. Let's look at alpha, and we know from the problem that the sine of A is equal to 3/5, so we're going to replace this with 3/5. The cosine of alpha is going to be 4/5, so we're going to replace this with 4/5. Then with the cosine of beta, we'll come over here, know that the cosine is -4/5, and we're given sine of B in our problem to be 3/5. So let's go ahead and replace all those things. All right, and now all that's left to do is to multiply and simplify. So if I multiply these first two fractions, I'm going to get -12/25. If I multiply the last two fractions, I'll get +12/25. And in this case, we will end up with a net result of 0. And that's that. Once you have this drawing set up, it's very easy to calculate the rest. Okay, so let's do the cosine of this sum. Cosine of alpha plus beta is going to be cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Let's go ahead and fill in the right things in the right spots, and we already know what those things are, so we just need to put them in the right spots. So we've got cosine of alpha is 4/5, cosine of beta is -4/5, subtracting sine of alpha of 3/5 and sine of beta of 3/5. All right, so we have, when we multiply, -16/25 minus 9/20. All right, now if I simplify that, I'm going to have -16 minus 9 all over 25, or -25/25, also known as -1. And the last one of these, we're going to have tangent of alpha plus beta. We're going to sub in the right things in the right spots. This time we have not calculated tangent of alpha, but we know tangent of alpha will be opposite over adjacent, or 3/4. Tangent of beta will be 3/-4, which is -3/4. So let's go ahead and put those fractions in the right spots. All right, so I've got +3/4 plus -3/4 in the numerator, and 1 minus 3/4 times -3/4 in the denominator. Well, It's going to give me 0 in the numerator over 1 plus 9/16. Well, we can calculate the denominator, but we really don't have to because we know that if we have a 0 in the numerator and something in the denominator, then we have 0 of something, right? 0 fourths or 0 sevenths or 0 1 plus 9 over 16, which is going to give us a net result of 0. There we go. So in this example, it's set up similarly, but we're given some different information. Okay, so we're given that angle alpha has a terminal side in quadrant 2. Okay, and we know that the tangent is -3/4. That means either the x value or the y value is negative, but since it's in quadrant 2, we know that the x value will end up being negative. All right, so here we go. We have a right triangle that looks like this. Let's go ahead and find the missing side, and you probably know what it is. Using the Pythagorean theorem, of course, we can solve for the hypotenuse or the r value. We know that the r squared will be 25, and we know r will be plus or minus 5, but we always know that the hypotenuse will be positive. So we can say that the hypotenuse here is positive. Oh, it gives us some good information. Now, angle B, we know, has a terminal side in quadrant 1. And we also know that the cosine of beta is 1/3. So we know that the x value is 1 where the hypotenuse is 3. So let's go ahead and solve for our y value. Pythagorean theorem again. 1 squared plus y squared is 3 squared. And then y squared will be 8. Y will be plus or minus the square root of 8, or plus or minus 2 square root of 2. Now we know this angle is in quadrant 1, which means our y value will be positive, so we can say that our y value is positive 2 square root of 2. Now once we have this information set up, we've got these handy dandy drawings, we can go ahead and substitute things in the right spots in the formulas. So let's go ahead and do that. For the sine of a sum, we have sine of alpha cosine beta plus cosine alpha sine of beta. We look at our diagram to find sine of alpha. We know that that's going to be 3/5. Cosine of beta will be 1/3. We're given that information. Cosine of alpha is going to be our x value over the hypotenuse, or -4/5. And the sine of beta will be the y value over the hypotenuse, or 2 square root of 2 over 3. All right, now let's go ahead and multiply each of those products. We have 3 times 1 over 5 times 3, or 3/15, plus -4/5 times 2 raised to 2 over 3. Now remember, when we multiply a constant times a radical that already has a constant in front of it, you're just going to multiply outside times outside. Leave the inside alone. So we end up with 3/15 plus -8 rad 2 over 15. Okay, there's not a whole lot we can do with this except express it as a single fraction, so that's what we will do. We'll say that this is 3 minus 8 rad 2 all over 15. All right, that one's done. Doing something similar for cosine of a sum, a cosine of alpha plus beta. We'll say cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Going to put the right things in the right spots. So we're just rearranging the values that we used in the sine of a sum to correspond with where they belong. All right, and then we're going to do the same thing. We're going to multiply. So we'll have -4 over 15 here, minus 6 rad 2 over 15 here. Now again, the only thing that we can do here is express it as a single fraction. So we have -4 minus 6 rad 2 all over 15. And we'll leave it like that. For tangent of alpha plus beta, again, we'll start with our formula. Put the right things in the right spots. Now we haven't done tangents yet, but we do know that the tangent of alpha is -3/4, so we are going to put that here and here. For tangent of beta, we know that this is going to be 2 rad 2 over 1. So that's going to replace these two blue tangent of beta. Okay, so this is what we have. Now we need to clean it up a little bit. Now what I see right away is both in the numerator and the denominator, I have a common denominator of 4. So I'm going to go ahead and multiply the numerator by 4 and the denominator by 4. And I can do that because that's really multiplying by 4 over 4, which is 1. So let's multiply everything in the top by 4. And that's going to get rid of this 4. That's going to end up being negative 3. And this will just be 2 rad 2 multiplied by 4, which is 8 rad 2. And the denominator, this will end up being 4. And then this right here is going to get rid of this 4, and it'll just be 6 rad 2. Notice we have a negative and a negative, so that will end up being positive. So this is what we end up with here. Now, I would be fine leaving it like this. However, if you need to simplify this further, you would multiply by the conjugate of the denominator, which would be 4 minus 6 rad 2, and you would multiply it in the numerator and the denominator. And that just about wraps up things for sum and difference formulas. We'll move on into a double angle topic, which is really just an application of a sum. And then we'll end up using that to find half angles. See you next time.